Hello, folks. This is the second part of the videos that I want to record to help you guys review for exam 2. As I said in the previous one, I'm going to do a few derivatives and also a few implicit differentiation problems. Okay, so let's just jump right into it. Let's share my screen. And okay, this is the first one. I have taken these problems, as I said before. I have taken these problems from the practice sheet, the practice sheets that I gave you over the last few weeks. And this is problem 20. I took this from the practice sheet from section 3.3. Okay. Yes, section 3.3. Okay, so let's get to this one. Let's start it. So f of t equals to 4 over this cubic root. Okay. Some of you may look at this and think of a quotient, right? Because I mean it's something over something, right? And that is actually not a bad appreciation. Like, yeah, it is a quotient, and you could do quotient rule on this one. But the thing is that, you know, when you do the derivative of 4, that is going to be 0, right? So, I mean, you would just keep that in mind, right? But the way I'm going to do it is different. It's not going to be a quotient. I will look at it as a power. Like, I'm going to rewrite this, and, you know, 4 divided by, I can rewrite this power, well, this cubic root, I can write it as a power, right? I can write it as 2t squared plus 1 raised to 1/3, right? Cubic root is the same as power 1/3. Okay, but then I'm going to bring it up. And to do that, I need to make the power negative. 2t squared plus 1 raised to negative 1/3. Okay, so you see that now this is maybe a bit easier to integrate. I mean, not to integrate, to differentiate. Right, because I mean, it's just a constant which we can disregard, and then we just need to do general power rule because it is a function being raised to a power, right? So I'm going to do that. F prime of t will be equal to, so we are doing ddt on this bit, right? The 4, we can put it as outside. So 4, and then ddt of 2t squared plus 1 raised to negative 1/3. Okay, I haven't taken yet the derivative, that's why I'm writing ddt. But now I'm going to do it. So 4, and then in the brackets, well, I'm going to do in the brackets first the derivative of this term. Power rule first, right? I'm doing general power rule, and that starts with the power rule. So the power comes down to the front and multiplies. Then we have the inside untouched. And the new power will be negative 1/3 minus 1. Okay, negative 1/3 minus 1. That's the same as negative 1/3 minus 3/3, right? 3/3 is the same as 1. And then we get minus 1, minus 3, minus 4/3. Okay, so that's my new power, not minus 4/3. And then I need to multiply by the derivative of the function of, well, the derivative of 2t squared plus 1. Well, for that, that would give us 4t, right? Okay, and then we close the brackets. We're done with that derivative. All right, so we can now combine stuff, right? So you see that I have 4, negative 1/3, and then have this 4 over here, right? So I'm going to, let's see. Put everything together. Oh, wait, I made a mistake. Yeah, I wrote plus 1 when it's actually plus t, sorry. So this should be plus t, and then plus t. And this should be a 4t plus 1, right? Because that plus t, when you differentiate it, you get 1. Okay, all right. Yeah, I was looking at my work, and yeah, it wasn't matching what I had over there. Okay, so now the constants multiplying 4 and negative 1/3, that becomes now, you know, minus 4/3. And then I'm going to move this one back down to the denominator, right? Because it has a negative power. So now notice that while I do this, while I'll do that with this thing, this 4t plus 1 stays in the numerator, right? Stays at like where it is. So 4t plus 1 and then divided by 2t squared plus t. Yeah, this was plus t. Sorry, I forgot to correct this one here. And then now the power is positive, right? 4/3. Okay. I could do then, just put everything together. So 4t plus 1, and then divided by 3 and 2t squared plus t raised to 4/3. Now I'm going to do another move, just to remind you guys of the properties of powers, fractional powers. And it's going to do with this term over here, okay? So remember that, okay, so let's think of 2t squared plus t as a single thing. So let's call it x, okay? And this x is being raised to 4/3. Okay, so remember that when you have fractional power, the numerator is the power, and then the denominator is the index of the root, right? So this is like x being raised to the 4th power, but then we are taking the 3rd root or the cubic root of it, right? Now, this x to the 4th, I can rewrite it as x cubed times x, right? And then because I can split the root, the cubic root, because what I have inside is a product, then I can write this as this and then times cubic root of x, right? So I have these two. Sorry, I'm going to give it some more space. Okay. Cubic root of something that is cubed, they cancel each other out, right? The cubic root and the cubic power cancel each other out. So I'm left with x only. And then here, well, it's just it. Like I cannot do anything to that cubic root. Okay, so I get with x times cubic root of x. So whatever my expression is, if it's raised to 4/3, I can write that as the expression outside of the cubic root times cubic root of the expression. So I'm going to do that to 2t squared plus t, right? So minus 4t plus 1 divided by 3. And then I'm going to, the expression, the x here is 2t squared plus t. So I write that outside. So 2t squared plus t. And then I need to do cubic root of my expression. 2t squared plus t. Okay, so I have that. Now I can do something else. I can pull out a t out of here, right? Minus 4t plus 1, then divided by 3t. If I pull out a t, I get then 2t plus 1. And then I have my cubic root of 2t squared plus t. And that's all I can do, I think. I don't see any other any further simplification possible. Okay, so this is the answer to this problem. Okay, again, we were doing the derivative, so let's not don't lose track of that. Okay, to the next one. For this next one, we have f of x equals to square root of x squared plus 1, all of that divided by square root of x squared minus 1. All right. So for this one over here, what we want to do is we could do several things, right? We could rewrite this as, powers instead of roots, like this. Or we could also bring this denominator up by making the power negative. So when you look at this, you think, oh, quotient, right? So you will do quotient rule. Of course, you would then do also general power rule on each term, right? But the overall, the outside rule, well, the differentiation rule that you will be applying to begin with will be the quotient rule. Now, when you look at this other one, this other version, you think of a product. So you will do product rule here if you wrote it that way, right? And what I'm trying to tell you guys here is that, you can do these derivatives in many ways. In fact, I can see another way of doing this, and that is that because the way it's written here, it's this term raised to some power, and then this other thing, sorry, this should have been a minus, this other thing raised to the same power. So when you have two things being raised to the same power, you can, well, in the case of a fraction, okay? In the case of a fraction, so if you have A over B and each one of them is being raised to, let's say, 1/3, then you can write the whole thing raised to 1/3. Well, we can do something like that in here, okay? And so we could do, so it's all equal, right? So x squared plus 1 divided by x squared minus 1 raised to 1/2. And we could do then on this one, we would do general power rule because it's some function being raised to power, right? But then when we do the derivative of the inside, we will be doing a quotient rule. Okay, so it's a bit like this way also, right? So let's see. So you see, we could do general power rule and then plus a quotient rule, right? So I've already listed 3 ways in which we can do this. Well, the way I'm going to solve this derivative is by using that last version. Okay, so we are going to do the general power rule first and then quotient rule. Okay, so f prime of x is equal to, well, I need to do the power rule, right? So 1/2 comes to the front multiplying, and then the expression raised to the power minus 1, 1/2 minus 1, that's minus 1/2, right? And then what I can do is, well, what I need to do is I need to do the derivative of the inside, right? Derivative of this quotient. And for that, I need to do the quotient rule. So quotient rule, remember, f over g, derivative of that is going to be f prime g minus f g prime divided by g squared, right? So here, derivative of x squared plus 1, that's 2x, times the second one without derivative, so x squared minus 1, then minus, I need to do now the first one without, times the derivative of the second one, so 2x again, right? Derivative of x squared minus 1 is 2x. And then all of that divided by x squared minus 1 raised to second power, right? Second one is squared, g squared. Okay, now there are many spots where I can do simplifications here, right? Let's see, we could turn this power positive by flipping the inside, right? We could do this, x squared minus 1 divided by x squared plus 1, and now the power is 1/2, right? Okay, let's now look at the numerator of our big quotient rule. So if we distribute, we get 2x cubed minus 2x, and then over here we get, what do we get? We get, again, 2x cubed, and then we would get 2x, right? 1 plus 2x. But because of this negative sign in front, everything here, when I do the distribution, everything here has positive sign, right? Well, there's a negative sign in front, which means that I need to distribute that negative onto everything that I got here, right? And because everything that I got here was positive, had positive sign, then they all will now turn negative. So I then do negative 2x cubed and negative 2x. Okay, and then I still am divided by x squared minus 1 squared. All right, now because I need to do more simplification and keep simplifying this thing, I do not want to multiply this out. I do not want to square it. Okay, now, if you are going to square it, do it correctly, right? I don't want to see something like this, which sadly I keep seeing. Okay, that's not right. I said it the first day, I will say it again many times. People keep forgetting. Okay, but I don't mind, telling you guys, reminding you of the rule. Okay, all right. Okay, so let's keep simplifying this. So 2x cubed and minus 2x cubed, they both cancel each other out. And then I have minus 2x, that is minus 4x, right? So 1/2, I'm going to get minus 4x divided by x squared minus 1 whole squared. Okay. Now, I'm going to do the backwards of this step over here, okay? Which is that because I have here this fraction being raised to 1/2, I'm going to distribute that power of 1/2 to the numerator and the denominator. So I will write x squared minus 1 raised to 1/2, and then divided by x squared plus 1 raised to 1/2. Okay, now I will then rewrite everything here, getting rid of this big parentheses over here. So, and multiplying everything out. So 1 times this is just that. So x squared minus 1 raised to 1/2, and then times minus 4x divided by 2x squared plus 1 raised to 1/2, and then I have x squared minus 1 raised to 2. You see that the x squared minus 1 shows up on the numerator and denominator. Therefore, I can do something with those powers. I should do 2 minus 1/2, right? And I will end up with one single x squared minus 1 in the denominator with that power. 2 minus 1/2, that's the same as 4/2 minus 1/2, that is 3/2, right? And that 3/2 will be the power of x squared minus 1 in the denominator. Okay, so I've got rid of this. So I now have minus 4x divided by 2. And then I have x squared plus 1 raised to 1/2. And I have x squared minus 1 raised to 3/2. Okay, now what else can I do? Well, let's simplify this and that, get 2. Now, another thing that I can do is I can rewrite this as a square root, right? And I can do that with this one over here as well, right? Because remember that, well, if I have y raised to 3/2, that's the same as y raised to the cubic power, and then we take the square root of that, right? I can write the y cubed as y squared and y, and then I can split that into that, right? And then the square and the cubic root here and the square root cancel each other out. So I have y and then square root of y, right? Which means that my expression y raised to 3/2, I can write it as this, which means that I can come back here and rewrite this x squared minus 1 raised to 3/2 like this, in this way. Let's do that. Let's see. I have now minus 2x in the numerator, and then I no longer have these two. I can write this first one as a square root, and then I have x squared minus 1, and then again square root of x squared minus 1. Okay, now I can take these two square roots and bring them together, right? Because if I have something like this and something like this, I can do square root of AB, right? So let's do that. Minus 2x, and then I have still x squared minus 1, and now I can bring those two square roots together and their insides, multiply them inside a single square root. So x squared plus 1, and then x squared minus 1. My OneNote is kind of acting weird. I don't know why. Okay, so the thing to notice now is that inside this square root, you see that you have almost the same thing, but with the medium, the middle sign different, right? And that should remind you of this other property. Okay, because now you can do minus 2x divided by x squared minus 1, and then square root of, well, this is our a, like here, right? And the result is a squared. So x squared is x to the 4th. And then minus b squared, our b here is 1. That would be minus 1. Right? And so that is our final answer here. Minus 2x divided by x squared minus 1, and then the square root of x to the 4th minus 1. That is our derivative. Okay. All right. Let's now do the third one. And this third one, the way it's written already, it's nice, right? Because like, yeah, well, this could be a quotient, right? Because this -3, you can make it positive by sending 3t squared minus 1 to the denominator, and then you will have a quotient, and then you will do quotient rule. But in my opinion, doing product rule is easier than quotient rule. I think it's easier to remember the formula. And it also is a shorter formula, right? Okay, so let's go ahead then and do it. As I said, I'm going to keep it like this. You could write as a quotient and do quotient rule, but I'm not going to do that. Although if you do it, you should get the same answer. Okay, so derivative. Okay, so product rule, remember, derivative of a product is the same as f prime g plus f g prime. Derivative of the first one, right? So derivative of this first one, that is going to be a general power rule because it's a function square, right? So 2t plus 3, and then new power 1, and then we need to multiply by the derivative of the inside. Derivative of 2t plus 3, that's just 2. And then we need to multiply this by the second function, unchanged. So 3t squared minus 1 raised to -3. And then we do plus the first one, not differentiated, so 2t plus 3 squared. And then now we need to do the derivative of this one. Well, again, general power, right? Function being raised to a power. So -3, and then 3t squared minus 1. Then this raised to -3 minus 1, that's -4. And then the derivative of the inside, that's going to be 6t. Right? Let's see what else we can do now. Let's rewrite this with denominators, okay? Because of the negative powers. So the 2 here and the 2 here gives me 4, and then 2t plus 3. And then I have denominator 3t squared minus 1 raised to the cubic power. And then I'm going to do plus, let's see what I have here. I have -3 and this 60, that is going to be minus 18t, right? So minus 18t. Let's actually get rid of the positive here and write minus, okay? And so then we can write 18t. We have then 2t plus 3 squared, and then divided by this, right? With positive power. So 3t squared minus 1 raised to the 4th power. Okay. Now that it's written like this, you see that there are many things that these two terms have in common. So I'm going to factor out as much as I can, right? So you see that I can, of the coefficients, I can pull out a 2 because they both are even. I can pull out 2t plus 3 because here we have 1 and here we have 2. And then I can pull out 3t squared minus 1, right? Because I have 3 here and I have 4 of them here. So I said I pull out a 2, I pull out a 2t plus 3, and I pull out also I pull out 3t squared minus 1. And then I'm left with, well, here I will be left with 2, and then you know, I got rid of this and that. So that's the only thing that remains, right? 2. Now for this other one, I still have the minus sign. When I remove 2 from 18t, I get 9t. And then I removed one of these, so I still have one of them. And then I still have 3t squared minus 1. Right? Okay. So this looks nice. I want to then combine these two. And to do that, I need to multiply 2 by this denominator and also divide it by it, right? So 2t plus 3 divided by 3t squared minus 1 raised to the cubic power. And then, as I said, I'm going to multiply these 2 by that 3t squared minus 1 and also divide it by it. And I have minus 9t, 2t plus 3 divided by 3t squared minus 1. I can then combine these two because they have the same denominator. Let's see what I get though. I get here 6t squared and then minus 2. And over here I get 18t squared and then plus 27t. Right? Now, I have a negative sign here, so I need to be careful with that. That negative will be distributed on this one and on this one. Okay, so let's see. 6t squared and then minus 18t squared, and then erase this. 6t squared minus 18t squared, that is minus 12t squared, right? Minus 12t squared. And then I have minus 27t and then minus 2. It looks like those are nice numbers for a quadratic. They're not. You're not going to factor this into two nice linear terms, okay? So don't worry about that. So then we have the denominator still 3t squared minus 1. We can now bring everything together. We can do 2 times 2t plus 3 and then times. Let's pull out this negative sign because it's in all of them and it kind of bothers me to see all these things negative. So I'm going to pull out -1 from there. If I pull out -1, then everything here becomes positive, right? Well, that -1 that I have pulled out, I'm going to then multiply with these 2. So then I have -2 here. Okay, but now everything here is positive. 12t squared plus 27t plus 2. And then all of these divided by, well, I have these 3 of them and have 1 of these. So my new denominator is to the 4th. Okay, and that is it. That is it, guys. This is g prime of t. And that's my answer. Okay. All right. I hope this process made sense and that you guys don't have too many questions. You know, of course, you can come ask me about the steps and so on, or send me an email. But these are the 3 harder derivatives that I chose to work out. Let's now do a few implicit differentiation problems, okay? I chose 3 different types of problems, 3 different types of implicit differentiation problems. Pretty much just so that you're aware of what kind of questions you could be asked, okay? So in this first one, I wrote down the statement. This was, of course, a list of 8 problems, 1 through 8. And for all of them, you had to do this thing that they say. But I'm going to just do one of them, number 6. Okay, and what they say here is that go ahead and implicitly differentiate this equation. And then they say, but then also take the equation, solve for y, and then find the derivative that way. Because they should give you the same thing. Well, not that they should give you the same thing, but they should be equivalent. And by that, I mean, you could get 2 different answers, but there's a way to get from one to the other one. And, if you do that, then you show that they are equivalent. Okay. So let's go ahead and solve for y first. Okay, so if we solve for y here, I want to keep the terms that involve y on one side and then everything else move it to the other side. So x squared y plus y, and then this minus 1 comes with positive sign, and then this x comes with positive sign. Right, now that I have it like this on the left side, I can factor out a y, and then I'll be left with x squared plus 1. And then I want to divide by x squared plus 1, right? Notice though that what I end up with here on the right side is a quotient with the same thing on the numerator and the denominator, right? So then I can simplify that, and that is actually just 1, right? A over a is 1. So if y is equal to 1, then dy dx, which is the derivative, is going to be 0, right? Because y is a constant, right? Okay, so whatever. So the next thing that I need to do is I need to do implicit differentiation. Because what we just did is explicit differentiation, right? We wrote down we turned the equation, the implicit equation, into an explicit equation, and then to the derivative of that. We now will not bother solving for y and just go ahead and take the derivative of this entire thing. Okay, so then that means that we are doing ddx on the entire equation, which means doing ddx on both sides, right? So ddx of x squared y, and then minus ddx of x squared, and then plus ddx of y, and then minus ddx of 1, and then ddx of 0. The two constant terms go to 0, right? This goes to 0, this goes to 0. What else do I have? I have this thing over here I'm familiar with already, that's 2x. This thing over here, we saw already that this is just dy dx, right? And then here we need to be a bit more careful, because what we have here, x squared y, that's a product. X squared is a function and y is a function itself. So we have two functions multiplying each other, that's a product rule, right? So then when we do the derivative of this one, we should get the derivative of the first one, that's 2x, times the second one without, that's y, and then plus the first one without, and then derivative of the second one, which is y. Well, derivative of y will just be dy dx, right? And then we have minus 2x, we have plus dy dx, and then we have 0 and 0, so just equal to 0. Okay, now I get rid of the parentheses. If I get rid of the parentheses, I get 2xy plus x squared dy dx minus 2x plus dy dx equals to 0. I want to group all the dy dx terms on the left side. So x squared dy dx plus dy dx. And then everything else, I'll be sending them to the right side. So minus 2x gets sent to the right side with positive sign. And then the 2xy is now here, minus 2xy. Okay, now I can factor out dy dx, and I'll be left with x squared plus 1. Over here, I can simplify this, right? I can write 2x and then 1 minus y, pulled out 2x from both. And then the last step is dividing by x squared plus 1. So 2x, 1 minus y, divided by x squared, x squared plus 1. Okay, that's what we got for dy dx. Of course, it doesn't look at all like the dy dx that we found over here, right? And why is that? Well, I can actually show now that they are equivalent. So if you look at, 2x and then minus, we have 2x times 1 minus y. We found out that over here, we found out that y is equal to, let's use the highlighter. We found that y is equal to 1, right? So that means that we could come over here and write, instead of y, 1, right? And if we do that, we have 1 minus 1, we get 0. Right? 2x times 0, that's 0. 0 over anything. Well, x squared plus 1 is never 0. It's always any number, right? Any non-zero number. Because whatever number you choose for x, if you square it, you make it positive, and if you add 1 to it, you make it even more positive. It's never 0, right? So 0 divided by something that is never 0, 0. So dy dx actually is also 0 this way. Okay, so I have shown equivalence. Although, let me highlight here what we found for dy dx. Okay, all right. So that's it for the first implicit differentiation problem. The second one is just regular implicit differentiation. So let's just go ahead and do ddx of everything. So ddx of x plus y squared raised to the 10th power, and then ddx of x squared plus 25. Okay, well, this could actually just be, ddx of x squared and then plus ddx of 25. Okay, so as before, this goes to 0, right? This thing over here we are familiar with already. That's 2x, derivative of x squared. Now this is the complicated part, right? Okay, so x squared, x plus y squared raised to the 10th power. You want to see that as a function. Sorry, let me erase that. A function raised to a power. Okay, so you want to do on that, you want to do general power rule. So if we do that, we get 10 and then x plus y squared raised to now the 9th power. And then we need to multiply by the derivative of this, right? The derivative of x plus y squared, that will be the derivative of x, which is 1, plus derivative of y squared. Derivative of y squared. Well, we know that when we see something like this, because y is a function of x, we have to do, again, general power rule, right? 2y dy dx. So then 2y dy dx. Okay, and that was it for the left side. Now on the right side, we had 2x plus 0. Well, we don't have to write plus 0. Okay, now remember that we also went for dy dx. So the thing to do now is dividing by this thing over here. Okay, we want to get rid of that. So if we do that, then we'll be left with 1, 2y dy dx equals to 2x now divided by 10 x plus y squared raised to the 9th power. All right. Now we want to solve for dy dx, then we want to send this 1 to the other side. So 2y dy dx, 2x divided by 10 x plus y squared raised to the 9th power, and then this one comes here with negative sign, right? And then we need to divide by 2y. But remember that divided by 2y is the same as multiplying by 1 over 2y, right? I want to write it that way on the right side, because if I divide everything, I mean, what I have on the right side is already a big thing. If I divide it by 2y, then it's, it becomes messier. But it's better if we remember that dividing by something is the same as multiplying it by 1 over that, right? So I'm multiplying what I have on the right side by 1 over 2y. Okay, so on the left side, I'm finally left with only dy dx. But now when I'm multiplying all of this by 1 over 2y, that's the same as I want to now distribute that 1 over 2y. If I distribute it on the first term, then the 2y is now multiplying the denominator, right? So 2x divided by 10, 2y, and then x plus y squared raised to the 9th power. And then minus 1 over 2y. I can simplify this a bit more. The 2's cancel out, and I'll be left with dy dx being equal to x divided by 10y, right? And then x plus y squared raised to the 9th power minus 1 over 2y. You could now combine these two and so on, but it's not really necessary. Although let me know if you end up with a nicer expression after doing that combination. Okay, but this is what we should get. This is what where I'm going to stop. I don't see the point any further. Okay. Now the next type involves taking involves differentiating implicitly, but at the same time, it also involves doing something else. We want to find an equation of the tangent line to the graph of the function defined by this equation. So this equation over here is defining actually a curve. It may not be a function, okay? Because I mean, x squared plus y squared equals 9. This is the circle of radius 3 with center at 0, 0, right? And that is not a function because when you do the vertical line test on it, you cross it twice, right? So this equation over here has this curve, but doesn't represent a function. Okay, so what I'm trying to say is that functions are not the only thing with curves on the xy plane. An equation like this also can represent a curve on the xy plane. Okay, so I'm looking at the curve given by this function over here. Not function, sorry, by this equation. I'm looking at the graph of it. And whatever it is, I want to find the equation of the tangent line at the point 1, -1. So let's say, of course, the point has to be on the curve, right? So let's say the point is this one over here. Well, I'm just trying to find the equation of the tangent line there. Okay. All right. Well, when we were looking at derivatives, when we were doing problems of this kind with explicit derivatives, we get the derivative and use the derivative to find the slope of the tangent line, right? Well, with this problem, we do the same, but instead of using f prime of x to find the slope, we will use dy dx to find the slope. So whatever expression you get for dy dx, you plug in these two numbers, and that's going to be your slope. Okay. This is x, this is y. Okay, so let's go ahead then and differentiate implicitly this expression over here. So again, that implies doing ddx on both sides. Right? We are familiar with what we have on the right side. That's just 1, right? ddx of x, I mean. Now over here, again, we have a function being raised to a power. So that implies that we need to do the general power rule. So 3x minus y minus 1 raised to the second power. Now we need to do the derivative of x minus y minus 1. Right? The derivative of x is just 1. The derivative of y is dy dx. And then the derivative of -1, that's 0. Okay? Equals to 1. All right. I want to solve for dy dx, so I'm going to get rid of this thing multiplying my expression involving dy dx. So when I do that, I end up with 1 minus dy dx equals to 1 divided by this, what I chose to get rid of, right? 3x minus y minus 1 squared. And then I want to solve for dy dx. Over here, dy dx has negative sign. So I'm going to do this. I'm going to send this negative dy dx to the other side because that way I make it positive, right? And also I will take this and send it to the other side, right? Because I want to end up with dy dx on one side by itself. So let's see what I end up with. Well, 1 here is positive, but then when I send this fraction to the left side, because it has positive sign over here, it will come to the other side with negative sign. I hope this makes sense. Okay, and now dy dx had negative sign. Now on the right side, it will have positive sign. But you see that now I have written, I have solved for dy dx, right? Okay, so this is my dy dx expression. I'm going to use this to find the slope. Okay. And for that, as I said before, I need to plug in 1 for x and -1 for y into here. So I get 1 minus 1 divided by, and what I get 3 times, and then 1 minus y is -1, so -1 there, careful with the signs, and then -1 squared. Here, what do I get? I get 1 plus 1 and then -1. I get, this is what? This is 1, right? Okay, so I get then 1 minus 1 over 3, because, this one was still squared, but 1 squared is just 1. And then 1 times 3, that's just 3. 1 minus 1/3, that's just 3/3 minus 1/3, that is 2/3, right? So that's my slope. Okay, and the point is 1, -1. So then I just need to write down, to plug them into my point slope formula, right? I get y plus 1, because this is a -1, and then 2/3 x minus 1. I get y equals to 2/3 x, and then 2/3 minus 1, that's minus 2/3. And then this plus 1 is now here with negative sign, right? Minus 1, but I want to write my 1 as 3/3. Okay, and so I end up with 2/3 x minus 2/3 minus 3/3 minus 5/3. And that is my answer. That is the equation of the tangent line. Okay, and that's it. I wanted to do these 3 kinds of implicit differential problems, and also wanted to do those 3 hard derivatives. I'm planning to make another video about a few homework problems. I think I'm going to do that later on today. But yeah, this is it for these problems. I hope these videos will help you guys study. Okay, and see you guys on the next one, maybe.